Hello everyone, welcome to today's class. So in today's class, we will study some CBSE previous year questions based on the topic relations and functions. So let's start. The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of our content may have been generated using generative AI, which is experimental. Okay, let's move to our question. The first question says, let set x is equal to 1 to 3. We have a set x having elements 1, 2, 3. And the relation R is defined in x as 1, 3, 2, 2, 3, 2, right? Then minimum ordered pairs which should be added in the relation R to make it reflexive and symmetric are clear. So this question was asked in CBSE term 1 21 to 2022, right? And the options are 1 1 2 3 1 2, option B 3 3 3 1 1 2, option C 1 1 3 3 3 1 2 3, and option D are 1 1 3 3 3 1 1 2, right? So we basically have to find that minimum number of ordered pairs that should be added in the relation R to make it reflexive and symmetric, right? So first we should know what is reflexive and what is symmetric relations, right? So a relation is called reflexive relation if and only if for reflexive the condition is AA should belongs to A, right? AA should belongs to R for all A belongs to A. Got it? This is the condition of reflexive relation, right? So suppose we have a set X as 1, 2, 3, right? So to make it reflexive, R must have 1, 1, 1, 1. R must have 1, 1, 2, 2 and 3, 3. Clear? R must have 1, 1, 2, 2 and 3, 3. Got it? Now, for symmetric, the condition is if AB belongs to R, this imply BA must belongs to R, right? If AB belongs to R, this imply BA must belongs to R. So if this condition is satisfied, we can say that the relation is symmetric relation. Got it? Clear? So suppose 3 2 is there in the set, so 2 3 must be there. Got it? If 1 3 is there, then 3 1 must be there. Got it? For this to be reflexive. Got it? So in this way you can think about or solve this question. After that, solve this question. So you have 10 seconds to solve or think about this question. After that we will discuss the solution part, right? Okay, let us move to the solution part. See, the question was we had set X which is 1 2 3 and we basically have to define a relation R in X, as R is the elements and ordered pairs in R which are already there is 1 3 2 2 and 3 2. Then minimum ordered pairs we should be added in the relation R to make it reflexive and symmetric, right? Let's see. So correct option will be option C, right? Clear? So you all have said that option C is right. Very good, option C is right. Okay, so let's see the solution part. So let's move to the solution. See, if R is reflexive, then it must contain 1 1 2 2 3 3. Clear? 1 1 2 2 and 3 3. Got it? And the relation R already have 1 3 2 2 and 3 2. So 2 2 is already there. So we just have to add 1 1 and 3 3, right? Since 2 2 belongs to R, so we need to add 1 1 and 3 3 to make R reflexive, right? We have to make R reflexive. Now, for R to be symmetric, see 1 3 is there, so we must have to add 3 1. Clear? And 3 2 is there, so we must have to add 2 3. Got it? If R is symmetric, if it contains 2 2, 1 3, see 2 2 is already there, 1 3 was there, so we must add 3 1. If it had 3 2, we must add 2 3, right? Since 2 2 1 3 and 3 2 belongs to R, so we need to add 3 1 and 2 3 to make it symmetric, right? So overall, what we need to add in total? Thus, the minimum ordered pairs which should be added in relation R to make it reflexive and symmetric are basically 1 1 3 3, 3 1, and because 1 3 was already there, so we must have to add 3 1 and 2 3. Got it? Clear? So we just have to add we just have to add 1 1 3 3, 3 1 and 2 3, right? Okay, let us move to the next question. So in this, option C is correct, right? So let us move to the next question. The next question says, check whether the relation R in the set Z of integers defined as R is equal to A, B such that A plus B is divisible by 2 is reflexive, symmetric and transitive, right? Write the equivalence class containing 0. Got it? And this question was asked in CBSE SQP 2020 to 2021, right? Okay, so we just have to check whether the defined relation is reflexive, symmetric or transitive. Clear? So what is the condition of reflexivity? As we have discussed, the condition of reflexivity is AA must belongs to set R. AA must belongs to the relation R. For all A belongs to A. Got it? For all A belongs to A. Clear? That is, suppose if you have suppose one set of 1 2 3, then for this set to become symmetric, it must contain the ordered pairs 1 1, right? 1 1, 2 2 and 3 3. Clear? It must contain these things, right? Okay. Now for symmetric, what should be the condition? If AB belongs to R, if AB belongs to R, this implies BA must belongs to R. This is the condition of symmetric. If AB belongs to R, this implies BA must belongs to R, right? So if 1 2 belongs to R, this implies 2 1 must belongs to R, right? If 1 2 belongs to R, that this implies 2 1 must belongs to R. Got it? Then only it will be symmetric. Got it? Now what is the condition case for transitive? What is the case for transitive? Transitive relations, the condition is if AB belongs to R and BC belongs to R is there, this implies AC should belongs to R, right? If AB belongs to R and BC belongs to R, this implies AC belongs to R. This condition should be satisfied. For example, if 1 2 is there, right, and 2 3 is there, this implies 1 3 should be there, right? This implies 1 3 should be there, right? So these conditions are basically for reflexive, symmetric and transitive. So in this question, we just have to check whether all the three conditions are satisfying or not, right? Okay. So let us move to the solution part. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. So the question was, we basically have to check whether the relation R in the set Z of integers defined as R is equal to AB such that A plus B is divisible by 2 is reflexive, symmetric or transitive, right? And also we basically have to write equivalence class containing 0, right? So let us move to the solution. So what should be the condition of reflexive? Since what was the condition of reflexive? A must belongs to R, right? A must belongs to R, and the relation is AB is divisible by 2. Therefore, we can say that A plus A equals to 2A, which is even, right? And which will always be divisible by 2, right? A plus A equal to 2A, which will always be divisible by 2, right? Therefore, we can say that AA belongs to R for all A belongs to Z, right? Hence, we can say that the relation R given is reflexive relation, okay? Now, let us check for symmetric. What can we say about symmetric? What was the conditions of symmetric? If AB belongs to A, if AB belongs to R, this imply BA should belongs to R, right? Clear? So if AB belongs to R, then we can say that A plus B suppose is 2 lambda, right? A plus B is equal to 2 lambda. So if we can write A plus B as equal to 2 lambda, then B plus A will also be equal to 2 lambda, right? Therefore, we can say that BA is belonging to R. BA belongs to R. Hence, R is symmetric, right? So R is reflexive and R is symmetric also, right? Let us check for transitivity. For transitive, what are the conditions? The condition was if AB belongs to R and BC belongs to R, this imply AC belongs to R, right? This imply AC belongs to R. So if AB belongs to R and BC belongs to R, then we can say that, see, if AB belongs to R, then we can say that A plus B is equal to 2 lambda. And if BC belongs to R, then we can say that B plus C is equal to 2 mu, right? Now we basically have to prove that AC belongs to R. So how can we prove? So suppose this is equation 1 and this is equation 2. So adding equation 1 and 2, we will get A plus 2B plus C is equal to 2 times lambda plus mu, right? A plus 2B plus C is equal to 2 times lambda plus mu. So A plus C is equal to, we can move this 2B to another side. So A plus C is equal to 2 times lambda plus mu minus B, right? So A plus C is equal to 2 times lambda plus mu minus B. So A plus C is equal to 2k, right? A plus C is equal to 2k. Clear? Where lambda plus mu minus B is equal to k, right? Lambda plus mu minus B is equal to k, right? Hence we can say that AC also belongs to R, right? So AB belongs to R, BC belongs to R. So this proves that AC belongs to R. Therefore, we can say that the relation is transitive also, right? So we have already proved the relation to be reflexive and symmetric. Now we have proved that the relation is transitive also, right? Hence R is transitive. Now equivalence class containing 0 would be all the even numbers, all the even integers including 0, right? All the even integers including 0. Clear? Hence the equivalence class containing 0 is basically all the even integers including 0. Got it? Okay, let us move to the next question. Next question is question number 3, which says prove that the relation R on Z defined by R is equal to xy such that x minus y is divisible by 5, right? X minus y is divisible by 5 is an equivalence relation, right? This question was asked in CBSE OD set 1 2020, right? So you basically have to prove that the relation R on Z defined by R is equal to xy such that x minus y is divisible by 5. Got it? Is equivalence relation. Clear? So what is equivalence relation again? What are the conditions of equivalence relation? It should be reflexive, right? It should be reflexive. What is the condition of reflexive? A must belongs to capital A for all A belongs to A must belongs to R for all A belongs to A belongs to A, right? Clear? For the reflexivity. Now for symmetricity, what was the condition? If AB belongs to R, this imply BA belongs to R. Clear? If AB belongs to R, this imply BA belongs to R. So we can say that the relation is reflexive relation. Third is transitive. So what is the condition of transitive relation? If AB belongs to R, AB belongs to R and BC belongs to R, this imply belongs to R, this imply AC must belongs to R, right? This imply AC must belongs to R. So these three conditions should be satisfied for a relation to become equivalence relation, right? So these three conditions must be satisfied, right? Equivalence relation, right? These three conditions must be satisfied. Okay, in this way you try to think about this question. After you have 10 seconds to solve or think about this question. After that we will discuss the solution part, right? Okay, let us move to the solution part. The question was, we have to prove that the relation R on Z defined by R is equal to xy such that x minus y is divisible by 5 is an equivalence relation. Okay, so let us move to the solution. For reflexive, we know the condition of reflexivity. X minus x, which will be equal to 0. So x minus x should be divisible by 5. So x minus x is 0 for every x belongs to Z is divisible by 5. Therefore, we can say that xx belongs to R, right? So xx belongs to R. Therefore, R is reflexive relation. Clear? So we can say that R is reflexive relation. Now for symmetric, what can we say? For symmetric, if xy belongs to R, this implies x minus y is divisible by 5, right? X minus y is divisible by 5. Therefore, we can say that y minus x is divisible by 5, right? Clear? We know that if x minus y is divisible by 5, then we can say that y minus x is divisible by 5, right? Therefore, yx belongs to R, therefore R is symmetric. Clear? Now for transitive relation, let xy belongs to R and yz belongs to R, right? Let xy belongs to R and yz belongs to R. Then we have to prove that xz should belongs to R. Xz should belongs to R, right? Clear? So if xy belongs to R, then we can say that x minus y is equal to 5 lambda, because x minus y should be, according to the relation, x minus y should be divisible by 5. So x minus y, we can write it as 5 lambda, right? So if yz belongs to R, this imply we can say that y minus z should be equal to 5 mu, right? Y minus z should be equal to 5 mu. Now adding these two, 1 and 2, we can say that, see, y and y will eliminate, right? Y and y will eliminate and we are left with x minus z on the left hand side. So x minus z is equal to 5 times lambda plus mu, which can be written as 5k, right? Which can be written as 5k. Got it? So we can say that xz also belongs to R. Therefore, we can easily say that R is transitive, right? Because it has been satisfied the conditions of transitivity. So we can say that R is reflexive, R is symmetric, and R is transitive. Therefore, we can say that R is an equivalence relation. Okay. Hence, R is an equivalence relation. Got it? Clear? Okay, let's move to the next question. Next question says, if set A contains 5 elements and set B contains 6 elements, right? Set A contains 5 elements and set B contains 6 elements, then the number of 1, 1 and onto function mappings from A to B is. We basically have to find the number of 1, 1 and onto functions which can be defined from A to B is. Clear? So first we should know what is the condition of 1, 1 function and what is the condition of onto function, right? So what is the condition of 1, 1 function? 1, 1 function, the condition should be if f of x1 is equal to f of x2, this imply x1 should be equal to x2. This is the condition for 1, 1 relation. That is, for for every domain in set A, there must be only one image in set B, right? There must be only one image in set B. Now, what is the condition of onto function? Codomain should be equal to range, right? Codomain should be equal to range. That is, for every element in the set B, there must be a pre-image. There must be a pre-image in set A, right? There must be a pre-image in set A. Then only it will become onto function. Clear? So we basically have to check that. We have to find whether number of 1, 1 and onto mappings from A to B can be defined, right? So how many 1, 1 and onto functions can be defined? So you just have to apply these two conditions and find how many 1, 1 and onto functions can be defined, right? So in this way you can try to think about this question. After that you have 10 seconds to solve or think about this question. After that we will discuss the solution part, right? Okay, let us move to the solution part. The question was, if the set A contains 5 elements and the set B contains 6 elements, then we basically have to find the number of 1, 1 and onto mappings can be defined from A to B. Tushar Gupta says it is never onto function. Very good. It can never be onto function, right? Clear? Therefore answer is 0. Clear? Because we cannot we cannot find any relation which is both 1, 1 and onto from the given set, because set A has less element than set B, right? And the condition of onto function says that every element in set B must have a unique pre-image in set A, right? Clear? So let's move to the solution part. We know that if A and B are two non-empty finite sets containing m and n elements respectively, then number of 1, 1 and onto mappings from A to B is, number of bijective function from A to B is, we have a general formula. So if number of 1, 1 and onto mapping from A to B will be equal to n factorial if m is equal to n, right? If m is equal to n. Clear? If m will be equal to n, then we can easily say that number of 1, 1 and onto function will be equal to n factorial or m factorial, because m is equal to n. Clear? And it will be equal to 0 if m is not equal to n, right? So we can only define we can only define the bijective function from A to B when the number of elements in set A should be equal to number of elements in set B, right? But if m is not equal to n, then we can say that there are zero mappings can be drawn from A to B, which is both 1, 1 and onto, right? Okay. Given that here you can say that m is equal to 5 because set A have 5 elements and set B has 6 elements, right? So m is not equal to n here. Clear? Therefore m is not equal to n. So number of 1, 1 and onto mapping is equal to 0. Clear? Therefore option C is correct answer, right? Option C is the correct answer. Okay. Okay, let us move to the next question. Next question says, let set A have elements as 1, 2, 3, 4 till n and set B have elements A, B, right? Then the number of surjections from A to B is, we basically have to find the number of surjections. What is meaning of surjections? Number of onto functions we have to define, right? We basically have to find the number of onto functions from A to B. Clear? Number of onto functions from A to B. Clear? we basically have to find the number of onto functions from A to B. So what is the condition of onto function? We know that. What are the conditions of onto function? Codomain should be equal to range, right? Codomain should be equal to range, right? Codomain should be equal to range for the function to be onto function, right? Clear? So you must define the mapping from A to B such that B will be codomain, right? B will be codomain. Then it must be equal to range, right? It must be equal to range. Okay. Clear? In this way, you can try to think about this question. After you have 10 seconds to solve or think about this question. After that, we will discuss the solution part, right? Okay, let us move to the solution part. The question says let A is equal to 1, 2, 3, 4 till n and B is equal to AB, then the number of surjections from A to B, then number of surjections from A into B is. We basically have to find the number of surjections, that is number of onto functions from A into A to B is. So option will be option B. Option B will be right, that is 2 to the power n minus 1, right? 2 to the power n minus 1. Got it? You guys can switch off your camera. Clear? If you have any doubt, you can write it in the chat box, right? Okay. So answer is correct. Answer is option B, 2 to the power n minus 1. Let's move to the solution part. So solution says total number of functions from A to B is, see, how many total number of functions from A to B can be defined as 2 to the power n, right? 2 to the power n, we know that. Clear? Right? Number of into function, right? The number of function which is not onto, right, will be 2. Clear? Because B has 2 elements, right? B has 2 elements. Set B has 2 elements. So number of into functions can be defined from A to B is basically 2. Isn't it? Clear? Number of into functions can be defined from set A to B will be 2. Now we basically have to find number of onto functions. So from the total functions, it is either onto or it is into, right? Clear? Either it is onto or into. Clear? So if we have total number of functions 2 to the power n and number of into functions is 2, then what can be the number of onto function? So number of surjections, that is onto function from A to B, will be total number of function minus number of into function, that is 2 to the power n minus 2. Clear? 2 to the power n minus 2, right? Clear? Therefore we can say that option B should be correct. Okay, number of into functions, see, set A has 1, 2, 3 till n. See, what is into function? The function which is not onto, right, is into, right? The function which is not onto is into. That is opposite of onto is into, right? It should be never onto. So see, A has 1 to n element, B has suppose 2 elements. So number of into functions can be defined as 2 because B has 2 elements, right? Number of into functions can be defined as 2 because B has only 2 elements, isn't it? Therefore total number of onto functions will be basically 2 to the power n minus 2, right? Okay. Therefore option B will be the correct answer, right? Okay, let's move to the next question. Next question says, show that the function f from R to R defined as fx is equal to x square is neither 1, 1 nor onto function, right? We basically have to prove that the fx is defined from R to R, fx is equal to x square is neither 1, 1 nor onto function, right? So again, what is on 1, 1 function and what is onto function, right? So 1 function is if f of x1 is equal to f of x2. Clear? This imply x1 should be equal to x2, right? x1 should be equal to x2. Then we can say that it is 1 function, right? For 1 function. And for onto function, if codomain is equal to range, right? Is equal to range, we can say that the function is onto function, right? So another method to find the function is like 1 function is to draw the graph. See, if we can easily draw the graph of function, we can easily say that the function is 1 or not, right? You can easily draw the graph of function y. What is the graph of function y equal to x square? This one. Clear? This is the graph of y equal to x square. So if you can draw any line which is parallel to x-axis, right? Parallel to x-axis, and it is cutting the point. It is cutting the curve at more than 1 point, then we can say that the function is not 1, right? Function is not 1, but it is many 1, right? Function is minimum function. And if it cuts at only 1 point, then we can say that the function is 1, right? Okay. So in this way, you can try to think about this question. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part, right? Okay, let us move to the solution part. The question was, show that the function f from R to R defined as fx is equal to x square is neither 1 nor onto, right? We have to define whether it is neither one. We have to show that the defined function as fx is equal to x square is neither 1 nor onto. So let us move to the solution part. See, the given a function f from R to R defined as fx is equal to x square, right? Fx is equal to x square. So for 1 here, x is equal to 1. See, at x equal to 1, y will be equal to 1, right? Fx is equal to 1, right? So if we put x equal to 1, we can say that f1 is equal to 1, right? F1 is equal to 1, right? And at x equal to minus 1, when we will put x equal to minus 1, so f of minus 1 is also 1, because minus 1 square is 1. Clear? So we can say that for the two values in the domain of the function, there is single value in the range of the function, right? Clear? Which can never be 1. Clear? Thus f1 is equal to f minus 1 is equal to 1, but 1 is not equal to minus 1. What was the condition? If f of x1 is equal to f of x2, this implies x1 was equal to x2. x1 should be equal to x2. But here f1 is equal to f of x1 is equal to f of x2, but x1 is not equal to x2, right? x1 is not equal to x2. So we can say that it is not 1 function, right? Clear? Now, so f is not 1 function. Now let us see whether it is onto or not. So what is condition of onto? For the condition for onto, codomain should be equal to range. Here its codomain is all real value. Codomain is all real value, but range. See, for onto function, let y belongs to R is codomain. Y belongs to R is codomain. Be any arbitrary element. Then y is equal to fx. Therefore, we can say that y is equal to x square, right? Y is equal to x square. So x is equal to plus minus root over y. X is equal to plus minus root over y. Now for y is equal to minus 2 will not belongs to R. Therefore, x will not belongs to R, right? Clear? So f is not onto function. Clear? So for negative values of x, there will not be negative values of y, right? There will no any values of y which is negative. Clear? So codomain is not equal to range. The range of this function is always positive number, right? Always non-negative number. The range is always non-negative number, but the codomain is all real value. So codomain is not equal to range. Therefore, we can say that the function f is not onto function, right? Clear? Hence, the given function is neither one nor onto. We have proved that, right? The given function is neither one nor onto, right? Okay, let us move to the next question. Now we have to show that the function f from n to n given by fx is equal to 2x is 1 but not onto. We have to show that the given function is 1 but not onto. Again, let's discuss what is 1 and what is onto. So 1 again, if f of x1 is equal to f of x2, then there must occur x1 is equal to x2. Clear? And vice versa can also be correct. That is, if x1 is equal to x2, then there must be f of x1 should be equal to f of x2. Then only this is the condition for 1 right? This is the condition for 1 Clear? And for onto, codomain should be equal to range. See, here n is codomain and it should be equal to range, right? Codomain should be equal to range. Then only it will become onto, right? So in this way, you can try to think about this question. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let's move to the solution part. The question was, show that the function f n to n given by fx is equal to 2x is 1 but not onto. So let's move to the solution part. Given a function f from n to n defined as fx is equal to 2x, right? For 1 let x1 x2 belongs to n, right? Let x1 x2 belongs to n such that f of x1 is equal to f of x2, right? F of x1 is equal to f of x2. Therefore, we can say that 2x1 is equal to 2x2, right? 2x1 is equal to 2x2. Therefore, we can say that x1 is equal to x2. So f is 1 function, right? Because we have proved that if f of x1 is equal to f of x2, then x1 is equal to x2. So f is equal to f is 1 function, right? For onto, let y belongs to n. Y belongs to n is in the codomain. Be any arbitrary element, right? Then y is equal to fx. Y is equal to fx. So y is equal to 2x can be written as y is equal to 2x. So x is equal to y by 2. X should be equal to y by 2. Clear? So for y is equal to x is equal to y by 2. So for y is equal to 1, x is equal to 1 by 2, which does not belongs to natural number, right? Which does not belongs to natural number. Clear? So for any odd number, that is odd number in its range, there will not be any pre-image in its domain, right? Clear? Thus y equal to 1 belongs to n. Codomain does not have a pre-image in the domain n. So we can say that f is not onto, right? So we can say that f is 1 function, but it is not onto function. Clear? Right? Okay, let us move to the next questions, right? This question says, show that the function f from R to R defined by fx is equal to x upon x square plus 1, fx is equal to x upon x square plus 1 for all x belongs to real is neither 1 nor onto, right? We have to prove that it is neither 1 nor onto. Clear? We basically have to prove that it is neither 1 nor onto. So again, we can discuss the condition for the function to be 1 1. What is the condition for the function to be 1 1? It should be C. If f of x1 is equal to f of x2, then this implies x1 should be equal to x2. Clear? Or opposite is also correct. If x1 is equal to x2, this implies f of x1 should be equal to f of x2. Clear? This is the condition of on 1. Now what is condition of on 2? Codomain should be equal to range. Here codomain is R and it should be equal to range. Codomain should be equal to range. Clear? So for the function to be 1 1, the above condition, this condition should be satisfied, and for the function to be on 2, this condition should be satisfied. Okay, so let us check whether these two conditions are satisfied in this question or not. If it is satisfied, then we can say that it is 1 1 on 2, and if it is not satisfied, then we can say that it is neither 1 1 nor on 2, right? So in this way you can try to think about this question. You have 10 seconds to solve or think about this question. After that we will discuss the solution part, right? Okay, let us move to the solution part. The question was, show that the function f from R to R defined by fx is equal to x upon x square plus 1 for all x belongs to DL is neither on 1 nor on 2. Let us move to the solution part. So let us check for first 1 1. Here fx is equal to 1 by fx. Why? See, fx is basically x upon x square plus 1, right? Fx is x upon x square plus 1. So what will be x 1 by fx? F of 1 by x. Put 1 by x in place of x. So 1 by x upon 1 by x square plus 1. Clear? So it will be 1 by x into x square upon 1 plus x square. So it will be equal to x upon x square plus 1. So you can say that fx is equal to f of x1, right? F of 1 by x, sorry. F of x is equal to f of 1 by x. Clear? For example, f of 2 will be equal to f of 1 by 2, right? F of 2 is equal to f of 1 by 2. So f is not 1 1, right? Because for 1 1 the condition should be f of x1 is equal to f of x2. This implies x1 should be equal to x2. But here f of 2 is equal to f of 1 by 2. But 2 is not equal to 1 by 2. Clear? So the condition of 1 1 is not satisfied here. Therefore we can say that f is not 1 1. Now checking for onto function. Let y equal to 1 belongs to R in the codomain, right? Y equal to 1 belongs to R in the codomain, then y is equal to fx is equal to x upon x square plus 1 is equal to 1, right? X upon x square plus 1 is equal to 1. Therefore we can say that x square minus x plus 1 equal to 0, which has no real roots, right? So clear? So if you solve this quadratic equation, then there is no real root. Clear? Hence range of f is not equal to codomain of f, right? Range of f is not equal to codomain. Therefore we can say that f is not onto function, right? F is not onto function, right? F is not onto function. Got it? Okay, let us move to the next question. Next question says, show that the function f defined from n to n given by f1 is equal to f2 equal to 1 and fx equal to x minus 1 for every x greater than 1 is onto but not 1 1, right? We have to prove that the function defined as fx is equal to x minus 1 for every x greater than 2 is onto. It is onto but it is not 1 1. We basically have to show that. Okay. So again we can discuss the properties of 1 1 and onto. What is the 1 1 function? F of x1, if f of x1 is equal to f of x2, this implies x1 should be equal to x2, or if x1 is equal to x2, this implies f of x1 should be equal to f of x2. Clear? Either of the two conditions should be satisfied, and we can say that the function is on 1 1, right? For onto, codomain should be equal to range, right? Codomain should be equal to range, right? Clear? Codomain is equal to range. Clear. So by using these two conditions, we can say that the function is whether the function is 1 1 1 2, right, 1 1 many 1 or into. Clear. So in this way you can try to think about this question. You have 10 seconds to solve or think about this question. After that we will discuss the solution part. Okay, let us move to the solution part. So that the function f from n to n given by f1 is equal to f2 is equal to 1 and fx is equal to x minus 1 for every x greater than 2 is on 2 but not on 1. But not on 1. So let's move to the solution part. We have function f from n to n defined as f1 is equal to f2 is equal to 1, right? F1 is equal to f2 is equal to 1 and fx is equal to x minus 1 for every x greater than 2, right? F of x is equal to x minus 1 for every x greater than 2. Now for 1 1, since f of 1 is equal to f of 2 is equal to 1, therefore 1 have same image, right? 1 have same image, namely 1, right? Clear? 1 have same image, namely 1. Clear? 1 and 2 have same image, namely 1. So f is not 1 1, right? Therefore we can say that f is not 1 1. Clear? For on 2, note that y equal to 1 has two pre-images, right? Y equal to 1 has two pre-images, namely 1 and 2. Now let y belongs to natural number, right? And y not equal to 1 be its arbitrary element, right? Then y can be written as equal to fx and it can be written as y is equal to x minus 1, right? Y is equal to x minus 1. Clear? So x will be equal to y plus 1. Clear? X will be equal to y plus 1. Now since x is greater than 2, we can say that y plus 2 is greater than 2. Y plus 1 is greater than 2 for every y belongs to natural number and y not equal to 1. Thus for every y belongs to natural number, y not equal to 1, there exists x is equal to y plus 1 such that f of x is equal to f of y plus 1, right? Because x has been written as y plus 1. So f of x is equal to f of, if we write f of x is equal to f of y plus 1, so we can write it as f of x is, what is f of x? Is x minus 1. So f of y plus 1 will be, we can write y plus 1 in place of x, right? We can write y plus 1 in place of x, right? So f of y plus 1 is basically y plus 1 minus 1, which is equal to y. Clear? Hence f is on 2. Clear? F is on 2 because codomain is coming out to be equal to range, right? So we can say that f is on 2 function, right? Okay, let us move to the next question. Right, let us move to the next question. This question says, prove that the function f from n to n defined by fx is equal to x square plus x plus 1, fx is equal to x square plus x plus 1 is 1 1 but not on 2, right? We have to prove that the given function fx is equal to x square plus x plus 1 is 1 1 but it is not on 2, right? And it was asked in CBSE Delhi set 3 2019 in the year 2019, right? So again we can write, we can try to find, try to apply the conditions of 1 1 and on 2. What can be the condition of 1 1 and on 2? Fx is given, so for 2 x1 and x2 we can write f of x1 is equal to f of x2, right? So if this condition will be satisfied, then we can say that x1 should be equal to x2. Then only we can say that the function is 1 1 function, right? And for on 2 function, codomain should be equal to range. That is, for every x in the domain, for every x in the domain, there must be a natural number in the codomain, right? And codomain should be equal to range. Clear? Whatever will be the range of this function, whatever will be the range of this function, it will equal to codomain, which is equal to n, right? Clear? So for on 2 we can say that codomain codomain should be equal to range of the function, right? Codomain should be equal to range of the function. Clear? So in this way, you can try to think about this question. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part, right? Okay, let us move to the solution part. The question is, prove that the function f from n to n defined by fx is equal to x square plus x plus 1 is 1 1, but it is not onto. So let us move to the solution part. Given fx is equal to x square plus x plus 1, right? It is given that fx is equal to x square plus x plus 1. Now for for one function, what we need to do, we basically have to do f of x1 is equal to f of x2, right? So for x1, x2 belongs to natural number, we can write f of x1 is equal to f of x2, right? F of x1 is equal to f of x2. So if we solve f of x1 is equal to f of x2, which will be x1 square plus x1 plus 1 is equal to x2 square plus x2 plus 1. So after solving this, see 1 and 1 will cancel out, and move this x2 square on left hand side, and x2 on again x2 on left hand side. So we can write x1 square minus x2 square plus x1 minus x2 is equal to 0. Clear? X1 square minus x2 square plus x1 minus x2 is equal to 0, right? So we can write, we can take, see, x1 square minus x2 square can be written as x1 minus x2 into x1 plus x2, right? Because we know that a square minus b square can be written as a plus b, right? We know this basic relationship, a plus b into a minus b, right? Isn't it? So x1 square minus x2 square can be written as x1 minus x2 into x1 plus x2 plus this x1 minus x2 should be equal to 0. Let us take x1 minus x2 as common, and after taking this common, we can find x1 minus x2 into x1 plus x2 plus 1 is equal to 0. x1 plus x2 plus 1 is equal to 0. Got it? Therefore the given function is 1 1, because after solving this we will get x1 is equal to x2, right? After solving this we will get x1 is equal to x2. So we can say that the given function is 1 1 function. Also, f is not onto function, as for 1 belongs to natural number, there does not exist in any x, right? Because see, suppose if we write fx is equal to 1, right, and solve this, x square plus x plus 1, right? So can there be any natural number which we put in which we put in place of n so that we get 1? No, there is no any natural number which we put in the domain will get the value 1. Clear? So there is no pre-image of 1 in the domain set, right? So codomain will not be equal to range here. Codomain will not be equal to range here. So we can say that the function is not onto function, right? The given function is not onto function. Clear? So we have proved that the given function is 1 1 function, but it is not onto function, right? Okay. Let us move to the next question, which says check which of the following function is onto or into. So f is from a to b given by fx is equal to 3x, where a is from set a is 0 1 2 and set b is 0 0 3 6. And question 2 says f is from z to z given by fx is equal to 3x plus 2, where z is equal to set of integers. We basically have to check whether the given function is onto or into, right? So you know the conditions of onto or into. So you will apply that. You have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let us move to the solution part. The question was, we basically have to check, we are given two functions and we basically have to check that out of the two functions, which of the function is onto or into, right? Question 1 was the function f is defined from a to b given by fx is equal to 3x, where set a is 0 1 2 and set b is 0 3 6, right? And question 2 was f is from z to z given by fx is equal to 3x plus 2, where z is equal to set of integers. So let us move to the solution part. Now we have a function f. We have a function f from a to b given by fx is equal to 3x, where a is 0, 1, 2 and b is 0, 3, 6. Let y belongs to b be any arbitrary element, right? We have assumed that y belongs to b be any arbitrary element. Then y is equal to fx. This implies y is equal to 3x. Y is equal to 3x. Therefore, we can say that x is equal to y by 3. X is equal to y by 3. So at y is equal to 0, we can say that x is equal to 0 by 2, 0 by 3, which is equal to 0. 0 belongs to a, right? Now, at y equal to 3, x is equal to 3 by 3, which is 1, which belongs to a. And at y equal to 6, so x is equal to 6 by 3, which is equal to 2, which is also belongs to a. Thus, for each element y of b, there is a pre-image in set a, right? There is pre-image in set a. So it is onto function. So function 1 is onto function, because for every elements in set b, there is a pre-image in set a under the condition fx is equal to 3x, right? Okay, let us move to the question explanation of second question. We have function f. Second function is f z from z to z given by fx equal to 3x plus 2. So let y belongs to z, that is codomain of f, be any arbitrary element. So y is equal to 3x plus 2, right? Y is equal to 3x plus 2. So we can say that x is equal to y minus 2 by 3. X is equal to y minus 3 by y minus 2 by 3. So for x to be integer, y minus 2 must be divisible by 3, right? For x to be integer, y minus 2 should be divisible by 3 always. So y minus 2 can be written as 3k, where k belongs to z. So y can be written as 3k plus 2. So every number in the range set is basically in the 3k plus 2. 3k plus 2. So codomain is not equal to range, because in codomain it is lying as integer z. Integer z. So codomain is not equal to range. Clear? So we can say that it is not onto function. So y is not onto function. Clear? Y is not onto function. Okay. So let us move to the next question. This question was asked in CBSE QB 2021. Question is, let R be the set of all non-zero real numbers, then show that the function f is defined from R to R given by fx is equal to 1 by x is 1, 1 and on 2. So you have 10 seconds to solve or think about this question. After that, we will discuss the solution part. Okay, let's move to the solution part. The question is, the set R be the set of all non-zero real numbers. Then we have to show that function f from R to R given by fx is equal to 1 by x is 1, 1 and on 2. So let us move to the solution part. Given as fx is equal to 1 by x, right? Given that fx is equal to 1 by x. So for 1, 1, let x1, x2 belongs to R such that f of x1 is equal to f of x2. F of x1 is equal to f of x2. So we can say that 1 by x1 is equal to 1 by x2. Put x1 and x2 in. What we have done, we basically have put x1 and x2 in fx is equal to 1 by x. So we can say that 1 by x1 is equal to 1 by x2. So after solving this, we can easily say that x1 is equal to x2 by doing reciprocal of both sides. So f is 1, 1 function. Clear? We can say that f is 1, 1 function. Now let us check for its onto function. For onto function, let y belongs to R be any arbitrary element. Then y is equal to fx. So y can be written as 1 by x. This implies x is equal to 1 by y, expressing x in terms of y. We have expressed x in terms of y. It is clear that for every y belongs to R which is in codomain, x belongs to R in domain. Thus, for each y belongs to real codomain, there exists x is equal to 1 by y belongs to R which is in domain, such that fx is equal to 1 by f of 1 by y. Fx is equal to f of 1 by y is equal to 1 by 1 by y, which can be written as equal to y, right? That is, every element of codomain has its pre-image in domain. So we can say that f is onto function, right? Okay. So hope you liked our today's lecture, and hope you understood all the concepts and all the questions. Thank you so much.